round of applause. And since we all live and breathe decentralization, Max is going to tell us more about this and how exactly they can be brought into the one ecosystem. Totally.
We're making a video with my phone? Yes. Thanks.
All right.
Thank you.
Thank you. That was quick.
Perfect,
Yeah.
great. So, hi. I'm going to stand behind this so you can see my beautiful presentation. So, first of all, thank you to Distributed Lab for this opportunity to speak here and for inviting me. My name is Max Kordek. I'm the CEO and one of the two founders of Lisk. Lisk is, in a sense, a blockchain application platform which enables developers to deploy sidechains and build decentralized applications on top of them. And today I want to give you a short introduction into Lisk and how we combine different decentralized technologies into one ecosystem, into the Lisk ecosystem. So, if we are looking back, we see that new decentralized apps are emerging rapidly within the blockchain industry, right? We had Bitcoin as the first one. Then many more, like Sires, Doge, Factor, Ethereum, Waves occurred. And these are only a few examples. There's Kulu, there's NEM, Scenario, Steam, Yotta, and so on. So there seems to be a demand, or many developers really want to build decentralized applications. So we at Lisk don't call them decentralized applications. We call them blockchain applications, and we want to enable people to develop these types of apps. But there are always problems, right? And in terms of blockchain applications, there are probably a lot of them. It's extremely difficult to program decentralized or blockchain-based applications. It's very time-consuming, and that's why it's also very expensive. Because if you implement a blockchain app from scratch, you have to work on so many different topics. You have to take care of the blockchain design, you have to take care of the peer-to-peer, the networking logic, you have to take care of the consensus, of the cryptography, and so on. And in the end, the developers can't really concentrate on the app itself because they have to take care about so much apps. And how would the solution look like? So, first of all, you would have to have a framework which allows you to easily develop a blockchain app, right? And in this framework, the developer would not have to care about all the complicated stuff I just told you about. Another point would be that this solution would have to be a network to create some kind of a synergy between all different apps on the network itself, so that these apps can communicate over this one channel, over this one network, and that the apps can share their functionalities with each other, so that the apps can grow more complex over time, right? It needs to be delegated, so you can implement third-party software into your own blockchain apps, and making the apps itself more feature-rich. And you have to have a token. Best if you have one universal token on the whole network, so you can leverage existing financial ecosystems like exchanges, payment processors, and so on, in order for the developers to monetize their apps. And well, I'm describing Lisk right now with this, and Lisk has a framework. It's a Lisk app SDK. It's written in JavaScript, and it allows the deployment of sidechains. It allows the development of the backend and the frontend of an app. It allows you to set up API calls, and it takes care of all the complex parts in the background, like peer-to-peer and networking and consensus and so on. It has a network. It's live for about 6 weeks now and already has over 300 nodes. It is delegated, running on delegated proof of stake, which Charles invented. And currently there are over 700 delegates on the network registered after 6 weeks. And it has its own token, currently with a market cap of around $30 million and a daily volume of $1 million. So app developers can really use this token and have an ecosystem in order to monetize their apps, right? And with this framework we offer at Lisk, you can build a lot of different types of applications. You can build social networks, messengers, online shops, prediction markets, sharing economies. But we think that, well, the blockchain doesn't make sense everywhere, okay? Sometimes you have only a smart part for your app where it makes sense to have a blockchain, where it makes sense to have consensus or a decentralized layer. And that's why we created some kind of a subcategory of blockchain apps. We call them blockchain services. And they are offering some decentralized features as a service. For example, you could have immutable storage. The blockchain itself as blockchain as a service for important metadata. You could have decentralized hosting for critical files like your family photos. You don't want them on Dropbox. It's better to have them, for example, on IPFS in an encrypted, splitted way. You can have decentralized computation for sensitive calculations, for example, for random numbers in a casino. You can have real opinions by the masses in order, or by oracles. And you can have smart contracts for truly trustless computation of code. In this kind, you can implement the EVM directly into Lisk as a sidechain, or can just plug into Ethereum, into the Ethereum network and ping to them and get a random number. I mentioned that we are utilizing sidechains, and that means every blockchain app on Lisk has its own fully customizable sidechain. So that means fully customizable means that you can integrate your own consensus algorithm, you can integrate your own block time structure and so on. But on a very low level, you can also decide to not change anything and just run with our framework if you really just want to concentrate on your app and you think all what we offer is great enough. And practically everything can be implemented into such a Lisk sidechain. This is the structure. So you have here the main chain, and now you can deploy a new sidechain, for example in the block 2, and it's running independently of the main chain in the network, and this allows a lot of cool things. It has a lot of advantages. One of them is scalability, even if Giacomo said it isn't, but in my opinion, this is like a huge first step towards scalability, because all app data is split into multiple smaller blockchains, right? And another one is usability, because the nodes only need to stay in sync with the blockchains they want. You don't need to sync like hundreds of gigabytes of data if you don't want to. So that means you have the main blockchain, and you have many different side chains where you can decide to sync them or not sync them. It's extremely flexible. That means the developers have complete control over the sidechain design and parameters, so they can really change everything what they want. They can change the block time, as I said, or the consensus algorithm. And it's quite protected. For example, in case of forks, all what's going wrong is only going wrong in the sidechain. So the main Lisk blockchain stays quite unaffected. So if you need to fork something, you just fork the sidechain in this case. Additionally, we are using some kind of federated peg. That means the funds are not really on the sidechain. It's just some kind of a replication. And in the case of a wrongly implemented sidechain or something like that, the funds are still on the main chain and can be retrieved. But it also has some disadvantages, of course. The biggest one is security, because sidechains are really like new blockchains, right? And you always need a new set of nodes for securing your sidechain. And to conquer this disadvantage, we thought of a concept of the delegate marketplace, which connects developers with node operators. here is a small sketch how a decentralized network could look like in the case of Lisk. In the middle you have the red dots. These are representing mainnet delegates. At Lisk these are 101 nodes. And you have many other delegates in the system, okay? And these delegates could secure different blockchain apps and different blockchain services. And sometimes you need to have very specific specifications for your node. So let's say your blockchain app integrates Ethereum for the computation of smart contracts, or it integrates IPFS in order to store images, because you can't do that on the blockchain itself. So you have requirements for the delegates. This is just an ugly sketch of how this delegate marketplace could look like. But you have, in principle, a list of names, their productivity, that means how good they are, how many blocks they forged and they didn't forge, the location and which software is running in the background, and the price. And for example, in case of the location, you could develop a blockchain app which might be legal in your country, but is illegal in other countries. And if you now have a sidechain and you have nodes securing this sidechain in this country where it's illegal, you might not want to do that because of regulations or whatever. So you have to decide, or you can choose exactly which location your node which secures your sidechain should be in. The same for like the software running in the background. If you're making, for example, a blockchain app which constantly scans the Bitcoin blockchain, and you have users in your app or something like that, and every time one of your users make a transaction on the Bitcoin network, you can put out a restart, for example. So you need to constantly scan the Bitcoin blockchain. But how to do that? Oracles are too slow, and plugging into centralized blockchain explorers isn't the best solution. So you really have to keep the Bitcoin blockchain in sync in the background. And because your app is secured by multiple of delegates, because it's decentralized, every delegate has to have Bitcoin running in the background, right? So you have to choose in this delegate marketplace delegates which have really Bitcoin running in the background. And of course this is being monetized, the delegates earn money, and this is the use case for the Lisk token on the network, or one of the use cases. Additionally to the delegate marketplace, there's another marketplace for the blockchain applications and services itself. It looks like that, only with one blockchain app on the testnet for now, but obviously you can do the same on the mainnet. And there you have an overview of all apps and all services running on the network, and you can just click on them, install them, launch them, and then play around with whatever functionality they have. So this was quite explained on a more general level. I'm not sure everyone gets what I said. So let me tell you one example. So this is probably one of the most used examples ever, but I really like that idea of a blockchain service for identity. What is an identity? An identity is unique information about a person which cannot be manipulated and can be used for authorization. It can't be manipulated because an identity never changed, right? And you should be able to use it for authorization in order to prove that this is really you. And in case of the unique informations, the data is saved in a database, right? And this data should be accessible on demand. So you're using a blockchain, which is some kind of a global ledger, so this information is available in the whole world if you want to access it. And encrypted because, well, your credit card information, for example, should be encrypted because you don't want that anyone just reads your data. You need some mechanism to authorize yourself. In the case of Lisk, this is extremely easy because you can just use the passphrase of your account. But for this case, obviously, this service should be trusted. And then you can simply log into the identity and prove ownership of that. And it has to be accessible for other apps, for centralized apps or decentralized apps. in order to implement them as a service. Nowadays you have like Facebook, Twitter, your email account, Amazon account, and so on, and you always have to input your same information again and again. Your name, your username, your email address, credit card information, and so on. With this service, you would have all these data saved on the blockchain, and these different websites only have to integrate this service into their website or into their app. And now you can only log in with the passphrase and have all the information accessible. And you can decide then what kind of information should be forwarded to the service itself. And again, yeah, it's really, well, revolutionary because the identity is really stored on a global ledger and is accessible from everywhere, okay? If you think about it, it's extremely powerful because now you have an encrypted identity you can use in every app, and there's no need anymore to sign up for a service and to input your information again and again, and you just need the service for authorization or for, well, for one-click shopping buys, for example. So, to sum it up, Lisk evolves into some kind of a worldwide cluster for apps and services everyone can use. And it's like a big brain because everything can work together. You can have this blockchain service like the identity, and you can have another one. And some developers might implement them both in their own blockchain app, and this is evolving over time. And this allows more complex and more feature-rich applications in the future. That's it. I know that it's quite generalized, but I had only 15 minutes and it was quite complicated to do this morning. So if you have questions, just approach me later or now, and I can help you out.
Well, actually, we have time for questions, but first, let's give an applause. Thank you so much, Matt.